Hello, my name is Jae Woong Yim. I'm a pharmacist. Have you ever heard of Mpemba effect? Its definition is hot water freezes earlier than cold water. What a nonsense! This is misunderstanding and mistake. But many people, even scientists, professors, and students, believe it is scientifically true. It is a huge complex. So now I will prove it is not true by some experiments. Two PET bottles, 1.5 liters each. I wrote hot for one bottle, cold for the other bottle. Then I boiled water. I poured 3 liters of water. Because this experiment is not for the absolute value, but for the relative value, distilled water is not necessary. Tap water is okay. The temperature is about 80 degrees Celsius. I poured water in each bottle. I filled it in same height. Then I tightened the cap to prevent the loss of water from evaporation. I put hot water in styrofoam box. And I put the cold water in iced water to cool down it. I designed my experiment like this because of some reasons. I searched the paper how Mpemba performed the experiment. Mpemba found this effect when he froze ice cream in the ice tray for the first time. And later, he performed the experiment with beaker. The beaker was not sealed. This is the first mistake. He didn't seal the beaker, so hot water evaporated a lot more than cold water. The amount of hot water was less than cold water. The second mistake is about the density. The water at 100 degrees Celsius is 4% lighter than the water at 0 degrees Celsius. Thus, 1 liter of water at 0 degrees Celsius weighs 1 kilogram. 1 liter of water at 100 degrees Celsius weighs 0.96 kilogram only. Mpemba used tap water for the cold water and the water from boiler for the hot water. He got same volume of each, but the density was different from each other, and the mass was different from each other. In conclusion, the hot water was 4% lighter than the cold water, and it evaporated a lot more than the cold water, so the hot water froze earlier than the cold water. In my experiment, the temperature was same, the volume was same, and the bottles were closed, so the physical value of each is equal. I cooled down the cold water, so now it is at about 5 degrees Celsius, and the hot water kept in styrofoam bags is about 70 to 80 degrees Celsius. I put both of them into the freezer. 5 hours later, the cold water almost froze and very small amount of water was not frozen. The hot water froze all, and the dew of the wall of the bottle is ice too. This is a diagram for it. The cold water almost froze and formed on clear ice, and very small amount of water was not frozen. The hot water formed clear ice, and the evaporated dew was frozen on the wall. Mpemba effect seems to be true through these results. But the reversal starts now. I dropped both of them on the ground and they were broken. As you see, the hot water was half of water and half of ice. It looked like being frozen, but unfrozen water was captured in the ice. But the cold water froze totally. It was not broken, and the amount of unfrozen water was unchanged. This is a diagram for it. The cold water froze totally, and very small amount of water was not frozen, but the hot water was half of water and half of ice particle. It looks like soft drink of a hamburger fast food store. It looks like refill drink with ice. In fact, the hot water freezes outer part only, but it freezes clearly, so the unfrozen water in it also looks like ice, and it makes confusion. I froze the hot water in the bottle like this to show you about it more clearly. And this picture is the section of it. The red colored part of this diagram. So I performed additional experiment to show it more clearly. There are two glass bottles, black color for the cold water, red color for the hot water. I painted different color to find easily when they are broken because of the expansion of ice. I poured boiling water at 100 degrees Celsius to overflow. Then tighten the cap and put the hot water in styrofoam box and cool down the cold water. Now the cold water is about 5 degrees Celsius and the hot water is about 70 to 80 degrees Celsius. I put them in freezer. I wiped water drops on the bottles and trays with a towel. 3 hours later, the cap of the cold water is pushed out by totally frozen ice. I imagined the ice would break the glass, but it was not broken because the cap was just pushed out. The hot water is not frozen yet, so the cap is not pushed out. The cold water froze totally, the ice expanded and pushed out the cap, so the cap cannot be tightened. But the hot water did not freeze yet. The cap can be tightened again. I put the hot water in freezer 1 hour more. Now the cap is pushed out. The expanded ice was attached on the cap inside. The cap cannot be tightened. In conclusion, Mpemba effect is not scientific truth, and it is just a happening of misunderstanding and mistake. Many people who believe in Mpemba effect say Aristotle, Francis Bacon, René Descartes also found the hot water freezes earlier than the cold water, but they are philosophers rather than scientists. Some people think the phenomenon of boiling water changes to snow when it is sprinkled as Mpemba effect, but it is because of small droplets due to weak hydrogen bond. If you spray cold water with a sprayer, the water will change into snow before it arrives at the ground. Water changed into ice because of the increased surface area, not the water is hot. Some people explain Mpemba effect with covalent bond. You can easily notice it is nonsense if you understand just high school chemistry. You need 920 kJ to break covalent bond of one water molecule. Notice that 920 kJ is for one molecule, not for 1 gram. If you want to break the covalent bond of 1 gram of water, you need to multiply 920 kJ for the number of molecules. So if you know how many molecules in 1 gram of water, you can calculate the total energy to break the covalent bond. 1 gram of water is about 0.06 mole. Mole is Avogadro's number, 6 times 10 to the 23rd. So 0.06 times 6 times 10 to the 23rd is about 3.6 times 10 to 22nd. Thus, water 1 gram has 3.6 times 10 to 22nd molecules. Do you remember 1 molecule of water needs 920 kilojoules? Molecules of water 3.6 times 10 to the 22nd times 920 kilojoule is 3.3 times 10 to the 25th kilojoule, and it is 3.3 times 10 to the 28th joule. It divided by 4 to transform to calorie unit. It is 8 times 10 to 27th calories. So you need the energy of the number of 27 zeros after 8 calories to break covalent bond of 1 gram of water. But you need only 100 calories to boil 1 gram of water from 0 degrees Celsius to 100 degrees Celsius. Notice the energy for Mpemba effect is 100 calorie, but for the covalent bond is 8 times 10 to 27th calories. It means the energy between hot and cold water cannot change the length of covalent bond. Covalent bond does not influence to the procedure of cooling or boiling water. So the trial to explain Mpemba effect with covalent bond is nonsense. People can easily notice it is nonsense if they understand just high school chemistry. But the problem is most people got low score in high school chemistry, so they just believe it because they don't understand. People always believe a difficult terminology and a special sentence, not the word they understand, because they don't want everybody to know their low score. The hot water freezes earlier than the cold water by accident. But why does not cold water boil earlier than the hot water by accident? That's because of latent heat. It takes very short time to reach at 0 degrees Celsius for both of hot and cold water, but it takes very long time to transform from water at 0 degrees Celsius to ice at 0 degrees Celsius. So the hot water started lately to freeze, but it takes long time for the cold water to transform to ice. The hot water has enough time to catch up, and it freezes clearly and it seems like ice. In the other hand, nobody boils water to evaporate all away. It is enough when water starts boil. It takes very long time to evaporate all water at 100 degrees Celsius, as same as water at 0 degrees Celsius freezes all. But when you say you are boiling water, it means water just reaches at 100 degrees Celsius, so it takes a very short time for both cold and hot water to reach at boiling point. Cold water has not enough time to catch up, and boiling water cannot boil partially, so nobody is confused. It is like running a race. When you run 100-meter race, if you start at 80-meter line, you will win the gold medalist. But when you run 1,500-meter race, if you start at 80-meter line, you cannot win the gold medalist. In my experiment, it takes only 1 hour and a half from 80 to 5 degrees Celsius, but it takes 5 hours or more to change into ice. The hot water has enough time to catch up the cold water, and moreover, its amount is smaller than cold water because of evaporation and density. You can imagine if you boil water to evaporate all, it will take 5 hours or more. But normally you don't boil water to evaporate all away. You always boil water to reach boiling point. It takes only 30 minutes or less. So the cold water has not enough time to catch up. It has no chance to turn around. Moreover, the density of cold water is higher than hot water. It weighs heavier than hot water, so it needs the time a lot more than hot water. That's why nobody observed cold water boils earlier than hot water even by accident. Thermodynamic principles are still available, and they are unchangeable truth, so people call them principles. Mpemba effect is not true. Thus, if you put hot water into freezer, it doesn't save electric charges. I recommend you to put water after cooling down it enough. This is the end of the experiment to prove the nonsense of Mpemba effect. Thank you for watching.